Okay, here we've got the vectors question. We're given points A and B and their coordinates, and we're given a line in the standard format for a line. So what we've got to do first of all is find the distance between A and B. So I don't think we need the line yet. We've just got two pairs of coordinates. So the way to do that in vectors is to find the vector AB by doing a subtraction of two position vectors, and then you Pythagoras that. So you do the square root of each of the terms in your vector from A to B and convincingly get to 3 root 3 as your answer. Then we've got an angle to find. So there's an acute angle, okay, with the line. So we need to find an angle. We're going to be using the cos theta recipe. In fact, we're going to stop at cos theta. We're not going to work out what theta is. So you know a method of working out cos theta with something dot something on the top and two square roots on the bottom. So you apply that, but in order to do that, you need to set up two vectors. So we're going to be doing a vector dot producted with another vector, and we're going to have two magnitudes of vectors on the bottom, and those two vectors are your directions. So we need to find what directions do I need to make the angle between. So one of the directions is going to be the vector from A to B, the line AB. Well, we've got the vector AB, so that direction vector will do. Now this line is more complicated than we need. We just need the part of this equation that tells us the direction. So you've got a column vector here and a column vector here, and those two column vectors, one of them does give you the direction, but the other one doesn't. So you need to pick out the one that gives you the direction vector. And then to get a start on part B, you need to start with two column vectors that are the directions that you need to find the angle between. So set up these two column vectors and then use the cos theta recipe, and you should end up with 9 over 7. Then finally in part C, the point P on the line L is where lambda equals P. So they're just saying that the point P is what this recipe generates when this value here is P. So it's telling us that OP, okay, the position vector of P is going to be the first column vector plus P times the second one. So this gives us OP in terms of the letter P, and that's the key to doing any question where there's a point on a given line. Okay, so you're going to take this expression, we know what OP is. Okay, but it asks us to do AP and dot that with the vector 1, 1, 1. So I've got OP from this. I need the vector OA, and OA is easy because I've got the position vector, I've got the coordinates of A. And if I've got OP and OA, then I can write down what the vector AP is. And if I've got the vector AP, and then I can do the scalar product of that with 1 minus 1, 1. I can dot them together, and I should get this answer. So that has led me through how to get these 4 marks here. Okay. Then this is hence. Hence find the coordinates of the foot of the perpendicular from the point A to the line L. Okay, well, if here's the line L and here's the point A, then the foot of the perpendicular from A to the line just means this point here. Okay, and this point is on the line, and look, they've encouraged me to refer to P as a point on the line, so let's assume that's P, and they've also made me find AP, which is this vector here, and they've made me dot it with something. What is this something I've dotted it with? Well, it's exactly this vector. It's the direction vector of the line. So they've set up what I need, in fact, to find perpendicularity. Yeah, to test whether things are perpendicular, then I take one of them, the vector AP, and I dot it with the other direction, and the direction of this line is this vector. So perpendicular means that the dot product is 0. Okay, so that's the thinking you need to go through, all right? But what you actually have to do is then very simple. We know that for perpendicularity, we need the dot product thing to equal 0, and that leads instantly to a value of P. And once I know the value of little p, remember the point P is just the point on the line where we take lambda to equal little p. So, if I know what this little p is, I can work out the position vector of the point P. And P is what they're asking for, the foot of the perpendicular. So if I get the coordinates of P via that process, finding the parameter little p from what I know this should equal first, that tells me the value of little p. Then substitute little p into this, or take lambda to equal that value of little p here. It's the same idea, and that will generate the coordinates I need. I hope that helps.